Can you hear us? Okay, perfect. Awesome. So I'm Caitlin McMillan, and I'm in my final year of chemical engineering at Dow.
And I'm Björk Avenson. I'm also in my final year of chemical engineering at Dow.
So today we're just going to give you a synopsis of what we believe chemical engineering is and a little bit of our experience from co-op. You want to see the slide?
Yeah, sure. Okay, so chemical engineering is related to chemistry, but there's a couple of key differences. So chemists generally work more on the lab scale, so they might do the initial lab work required to develop a new product. And then once the chemists have discovered something on the lab scale, their work is given to a chemical engineer who's going to figure out how to produce it on the big scale, so production level.
So chemical engineering is a scaled up version of chemistry. So we take something from the bench scale in the lab, and then we make it a little bit bigger into something called pilot scale. And then from pilot scale, we make it industry standard. So that's where production level actually happens, depending on if it's oil and gas or beverages or Gatorade, anything like that. So we want you guys to take a second to think, what do you think chemical engineers do? If you have any ideas, pop them in the chat. Otherwise, just think to yourself. Oh, maybe we should have waited until 9:15. We see that a few people are still entering the session, so we might, I think they split things. Maybe sometimes, depending on the experiment.
Not on purpose, I hope.
That's true.
Any other ideas?
Well, it's actually a really, really wide scale job, if you say. Oh, we still see some people are entering the session, so we're just going to give this a couple more minutes.
So you guys can think even more about what you think chemical engineers do.
I see that Shelby just entered this session. Shelby, can you let us know how many people are supposed to be in here? Produce large amounts of one product and how to do it quicker. That's a really good answer, yeah.
Pretty much.
We're always working on the optimal, well, I'm not quite there yet.
We will be.
But chemical engineers are always working on optimizing. All right, we're gonna pop to the next scale. So, slide, sorry.
Alrighty, so basically the difference between lab scale and production scale is if you think of a chemical reaction as an example, at a lab scale, it might, if it releases a lot of energy as heat, it's not really a big deal if you're in a lab because your volume is still pretty low, so the heat release might not be that big. But if you're looking at a production scale, that small amount of heat multiplied by the scale of your place or whatever would be significant. And so you got to be considerate of basically like how things are operating and how much heat you might be releasing. There also needs to be good mixing between reactants and catalysts in order for a reaction to be produced, or for a reaction to proceed. And so chemical engineers require knowledge of heat transfer, mass transfer, and fluid dynamics to design large-scale chemical reactors.
So this slide essentially just describes the basic chemical engineer's design process. So we take raw materials and then we put them through a specific process. And from that process, we have to inject energy of any type, depending if it's like heat, mechanical energy, really anything. And then from that process, we get a certain amount of waste and a certain amount of useful products. So what we really want to do is optimize the amount of raw material that we have to get the minimal amount of waste and the maximum amount of useful products. So the chemical engineer's challenge is, how do we balance the economic benefits and environmental impact of this process?
All right, so you guys might be wondering where chemical engineers work. The answer is basically anywhere. There's tons of examples, and I mean, our co-ops have been a bit limited. We'll talk about them later, just kind of based on what we're interested in, but you can work in petroleum refining, so like oil and gas, petrochemical processing, biofuels and biotechnology, the environment, so that'd be like wastewater treatment, air quality, process consulting, and also the food and beverage industry is not listed on here, but that's a pretty big one as well. So you can really kind of, whatever you're interested in, you can definitely pursue through a chemical engineering degree.
Awesome. So yeah, one area that you could work was pharmaceutical and nutritional processing. So a few people in our program, specifically Shelby Reed, she was in charge of Go and Scroll a little bit this year. She worked at a facility that produced certain types of vitamins in Halifax, or in the Halifax area anyways. So that's one area that you could work. So they produce different types of medicines and vitamins. Yeah. And then one area that I've worked in is nuclear technology. So I've done 4 co-ops actually in nuclear technology. My first co-op and second co-op were at CNL. It's a little plant in Ontario. Sorry, I had messages going up. I apologize. So I've worked in the nuclear energy sector a little bit. My first 2 co-ops were more on the research-based side of it, and then my last 2 co-ops were more in an industry that actually produces electricity. So they produced 33% of the energy for Ontario. I do a lot of random things as a co-op student. So I would be updating drawings, attending meetings, walking down facilities to see as-built conditions. And then, yeah, that's pretty much what I've done for my co-ops.
All right, so another industry that you might be able to work in is food processing. This one's also really common. There's quite a few people from our class that have worked at the Pepsi plant. There's one in Nova Scotia, and then there's a few all over, but we know people that have worked at least in the one in Nova Scotia, and also there's a plant in Vancouver. So food processing would be, you could be doing equipment trials, packaging room optimization, quality and consumer complaints, or looking at defective product reduction. So you basically just want to make sure that you're producing a consistent product every time and make sure that you're doing it efficiently.
There's also a lot of specialty products that chemical engineers focus on that you might not think a chemical engineer would be involved with, but they do need a chemical engineer on the team. So these are products that involve either chemical reactions or chemical separations. Chemical engineers are really the only engineers that study these concepts, so it's important that they're on these teams. One example is membrane systems. These are special materials that can be used as filters for applications like water desalination or medical devices. Another example is the design of new or improved chemical products like biodegradable cups. So you'll see the biodegradable cups in the top right hand of your screen right now. So yeah, a chemical engineer needed to be involved in this process. One thing below that is some alcoholic beverages, and they also need to be involved in that process as well, for taking it from making a small batch to making a really, really large batch. So York and I's our capstone project, which is like our final year project that we work on for 8 months this year. We're working with Labatt Breweries in Halifax to improve their filtration process. So we're very much involved in the brewing side of it right now.
All right, so here's just a breakdown of where co-op students work. So like we said, there is a big range of where you can work, not just industry-wise, but also provincially throughout Canada, and also you can work outside of Canada if you'd like. So as you can see, a high percentage work in oil and gas, as well as energy, and then there's mining, research, which is often with professors at a university, government, food, and paper. So at DAL, about half the students stay in Nova Scotia, with just over 1/4 staying in Halifax, and then the rest work mainly in Ontario, New Brunswick, and Alberta. So if you're thinking oil and energy, some of the companies that are more common would be Exxon, Imperial, Irving Oil, Shell, Suncor, which is where I did my co-op this past semester, and Syncrude. And then mining and metals would be Compass Minerals, Glencore, Goldcorp, Mosaic, and Teck. And then food and beverage, Molson, PepsiCo, which I mentioned earlier. And then paper and forest products could be J.D. Irving, Port Hawkesbury. So there's a big variety, and like I said, you can kind of basically whatever you're interested in, you can likely find some career in that field. All right, so I'll just go through a couple of the co-ops that I've done. So as well as Caitlin, I also did my first co-op at Canadian Nuclear Labs, which is in Chalk River, Ontario. My first co-op there was mostly doing lab work, so I was studying cable degradation. It was super interesting, but not necessarily for me, but it was a really great start, and it also it gave me a lot of skills within the labs and just kind of learning how engineers work. And then my second co-op was also at Canadian Nuclear Labs, but in a very different field. So I was working in their waste management group, and we were rolling out a new waste management program. So this was a lot of project management. I spent a lot of time on the phone trying to track down old plans and get things sorted out. And then my past co-op this past 8 months was at Suncor in Alberta. So I was working in their completions engineering group. So originally this was supposed to be a very much fieldwork based co-op. Obviously COVID happened this year, and so that changed. And so I was mostly working from home, but it was still a great experience and provided a lot of really interesting opportunities for me. So if you guys are thinking about engineering, co-op is definitely something you should consider.
Okay, perfect. So this slide just gives you a general overview of what courses you'd be taking if you took chemical engineering at Dal. So I'll just give you a brief overview. So there's a lot of science courses, a lot of engineering design courses, specialty courses, and experimental courses. So the science courses are very theoretical: chemical reactions, fluid dynamics, materials, organic chemistry, physical chemistry, thermodynamics, transport phenomenon, which includes heat mass and momentum transfer. If I was looking at this slide when I was in grade 10 or 9 or 11 or 12 or younger than that, I would have no idea what these were. So don't feel bad if you don't know what some of these words are. I didn't as well. So essentially, it's taking everything that you're learning in your science courses right now and really diving deep into a specific concept. And then your engineering design courses take those science-based theoretical courses and they apply the knowledge a bit more. And that's also what happens in the experimental courses. Both the engineering design and the experimental courses are fairly hands-on. So you're either working in groups, talking about a design, or you're in a lab working on an experiment and then writing lab reports based on that. There's some specialty courses. So these are bioprocess engineering, computer methods, green engineering, industrial safety and loss management, law and ethics, and process simulation. So some of the specialty courses you get to actually choose yourself based on your interests. So this semester I'm taking 2 elective courses, and one is project management. I'm more interested in the project management side of engineering, so that's probably where I'll be taking my future, so I wanted to take that course. And then I'm also in a brewing course, so I'm getting to learn the science behind making alcoholic beverages and fermented beverages in general. So yeah, that's fun.
So these are just some of the labs that we run in our pilot scale course, which is in your 4th year. So we do some labs using a distillation column. The second picture is a falling film evaporator. And then we have a plate hydraulics lab and a bubble column. So these are just kind of examples of some of the lab experiments that you get to do and what you get to learn. And then basically the idea is that you take the concepts that you learn in these labs and you'd be able to apply them to the big picture in a production scale area.
Oops, one more slide. So yeah, these are some more projects and lab experiments. There's a little time lapse that I'll play for you. So in this time lapse, I'm not sure, depending on internet speed, if this looks good or not. But we were working on separating two things with different boiling points in this experiment on the left-hand side. So what would be an example of this? Like
good grief, I'm blanking.
Juice. I guess juice. So like the water's in juice and the sugar's in juice, they have different boiling points. So you can separate them using this column that was just in that video. So that was a lab that we actually designed ourselves. And then we got to complete the lab and then write a report based on that lab. So we got to take an idea that we were interested in and then actually complete the lab by ourselves. And then we got to write a report on it and present it to our class. And then on the right-hand side, we're actually making aspirin. So this would be considered bench scale. We only made like enough aspirin for 1 dose. Yeah, so it was really interesting. We got to see how you take the raw materials and then we got a final product of aspirin. It took a couple of weeks, but yeah, it was really interesting. So the next slide is just questions. Do you guys have any questions or would you like us to go over anything again?
Feel free to put the questions in the chat, yeah. I don't know how to unmute people, so.
Yeah. I guess I should.
It can be about anything. You can ask about our co-ops, you can ask about classes, like Dal's program in general, why we decided to take chemical engineering.
Doing classes during COVID.
Yeah, what it's like working from home, anything. There's gotta be something. Oh, cool. How many co-op terms are there at Dal? So there's 4 4-month terms. So you do after your second year, so you do 2 full years, and that's like Dal's Diploma of Engineering program. And then you do your first summer after your 2 years, you do a 4-month co-op. Is it your summer or your fall?
Fall.
Fall, sorry. I do the fall. So you can do a work term in the summer if you'd like, but that's completely optional. So there's 1 co-op term in the fall, that's 4 months. Then you come back for your first semester of 3rd year, and then you go for the summer.
That's your second co-op in the summer.
Yeah, your second co-op the summer. And then you do your second semester of 3rd year, and then you have an 8-month term. So you can either do 1 8-month term or you can do 2 4s, depending on whether you'd like to do a longer co-op or try 2 different locations.
Yeah, and I guess I should mention here too that I did my first 2 years of engineering at St. FX, and then I graduated from St. FX with my diploma in engineering before I came to Dal. So we have a few more questions. Do you do chemical experiments at home since COVID? Not as many. We do have a lab course right now. Pretty much every semester in your final 2 years, you have some sort of lab course that you would be going into a lab and completing experiments. However, because this semester we can't go on to campus, we have been watching videos of our professors completing the experiments, and then they provide us with the data we need to complete the lab. There are a lot of computer courses that are like computer labs that we could be completing at home. One of our courses right now, we're actually going to be making essential oils. So we do get to complete that one at home. So that was another design-based lab. So we will be making lavender essential oils using a few different solvents. So we're going to be using hexane, hexane and acetone. So yeah, we're going to be making lavender essential oil at home within the next couple of weeks, which will be fun.
Mm-hmm.
Okay, we have this one.
So
when did you decide you wanted to be an engineer? I don't know if I've decided yet. I'm kidding. I decided my summer going into grade 12 that I was interested in engineering. Originally, I was interested in environmental engineering, actually. But once I got to university, I found out that environmental engineers deal a lot with like water waste and sewage. And I was a little less interested in dealing with sewage for the rest of my life. So I got a bit more interested in chemical engineering. But yeah, it was my summer going into grade 12. What about you?
So I kind of had a weird route about it. I come from a family where basically everyone's an engineer, so I wanted to do the opposite and do nothing to do with engineering at all. But I applied to one engineering program, which was DAL, and then I don't know, I think I just kind of realized that I liked all the courses, like the science courses, the physics courses, and it just kind of seemed like a good fit, so I decided to go with it. And I've had very few regrets, maybe during midterms a couple, but other than that, I've really enjoyed it. And I think, yeah, like if you're interested in sciences, maths, physics, and you enjoy doing them, it's a pretty great fit. What's the next question?
Yeah, and I guess I should mention that she comes from a family of engineers, and I come from a family that doesn't even know what engineering is. So you can do it no matter what your background is. Mm-hmm. What's the next question? Where do each of you want to go from here with your chemical engineering? Like, what careers are each of you interested in? Oh, interesting.
Thanks.
It's a scary question. I think that my next steps will probably be somewhere in the nuclear industry, just because I've completed 16 months already. I'm pretty settled down in the town where I'm at right now. So I think I'll be doing something with fuel remediation or in a tritium lab. So yeah, very nuclear based. But from there, I'm more interested in the project management side of it. So I'm going to be taking project management courses after I graduate, and then hopefully doing something there. I have also been interested in working at a brewing company, at a large-scale brewing company as well. So we'll see what happens, but probably nuclear. What about you?
I am pretty split. So I did, like I said, two co-ops in nuclear and 2 terms in oil and gas. I really liked my oil and gas co-op. I thought it was really interesting. I'm a little split on the industry, I guess you can say, but I think like my opinion is if you're working in oil and gas, you can be working to make it a more environmentally friendly option. So that's definitely an option for me. Nuclear could be an option. I'm also interested in brewing, so I have not made any final plans yet. I think anything could be interesting, and I'm pretty open to kind of just seeing where things end up. The next question is, what percentage is there of guys and girls in our classes? So I think we worked it out last year. I want to say like 20% girls. Does that sound right?
I think maybe I don't know. I think it was between 20 and 25, which is actually quite a high percentage. Sorry.
Yeah, especially compared to some of the other disciplines. Chemical is a bit more female-based. I don't really know why. Maybe it's just kind of how our interests align. But it has often been a bit more female than some of the other disciplines. But yeah, it's around 20-25%.
Yeah. So chemical is considered the girl engine, girls are in chemical engineering, so it's a higher percentage than all of the other ones, but it's still
low,
quite low. But the one thing is, a lot of girls attend class, so
it feels higher.
It feels higher than that percentage, and I've got to say, like, all of my friends are girls in chemical. Most of my friends in chemical engineering are girls, so there's definitely an opportunity to make it like a girl club. If that's what you're interested in.
Yeah, there's definitely lots of us.
Yeah. Okay, so do you take any classes besides chemical engineering?
I guess they're electives.
Yeah, so actually the first 2 years are just engineering, or like they're science, physics, engineering courses, but you take those classes with everybody in every discipline. So you're there with electrical students, mechanical students, industrial students. You all take the same classes in your first 2 years. And then your last 2 years, they're more specific. And then you get to choose some electives. And then some courses, they are chemical engineering based, but like, for example, we had to take a law and ethics course. So you wouldn't necessarily in your head think, oh, that's chemical engineering, but it's still important to the career path. So that's included in the courses you have to take, but it's not very like science theoretical based.
This one, 38 degrees. Technically, we have a diploma, but it's not like we went to like a college program where you take a technical diploma. In that sense, I would say more of a formality. I don't know what your thoughts are. Like, it's kind of like a halfway formality, and I think it's partly to do with because you can come from associated universities. So, like, Caitlin came from St. FX. You can do your first 2 years at Acadia, Cape Breton University, PEI.
Well, maybe not anymore.
There's a few others. Basically, anywhere on the East Coast. I think all of the universities do have the first 2 years that you can do there. So we don't have a degree yet, but we do technically have a diploma.
Yeah. Okay, so Kate, I'll give you a better explanation of what co-op is. So when you go into engineering, you have the choice to do a co-op based or just a course-based program. If you take the co-op, essentially what co-op is, it's an industry.
It's a job.
It's a job. So for 4 months, you're working in the industry of your choosing, sort of. So like to get a co-op, you have to make a resume, make a cover letter, and then apply to different positions. And lots of different companies all around Canada and all around the world, they have co-op programs for students. So you're applying to those jobs that are posted, and you can find them all around online. And then Dal also has specific co-op positions from specific companies in all around Canada. And then you apply to them, and then you get an interview to do with that company. And then if your interview is successful, you'll get offered a position. And then you work for 4 months with that company. And then you get to do that 4 different times. Some people do more than 4 months at that same company because they really like it. And then some people have 4 different co-ops at 4 different companies. Is that an explanation of it? So like when you're in co-op, you can do like lots of different things. So like you run meetings, you update drawings, you do calculations for them.
Often in your final like co-op too, they'll let you run like a project. So they'll give you basically, here's a problem, and you have to come up with like how you're going to fix it. So especially in your last one, you're essentially working as a junior engineer. So it's kind of just work experience through university, basically.
Yeah. Great, awesome. How hard was university compared to high school?
It's different. It's more.
Different. You have more work, so you're in 6 courses in comparison to 4 in high school. It's definitely harder, I would say. Like the course material gets harder pretty much every year. And then your final 2 years, the like hardness, the difficulty is very similar. It's definitely harder. It's challenging, but it's not out of your reach. If you're in science courses right now, it's not out of your reach. And there's like so many resources to help you get through. So there's like always tutors. Your profs are the profs in chemical engineering are amazing. And they love getting questions from you. And then
they love it.
Yeah. The other thing is like you're surrounded by people who are taking the same courses as you and going through the same thing. So it's very like group work oriented. So you're like, what did you get for question 1? It's like, then you compare like on your assignment, like, okay, this is how I did it. How did you do it? Comparing. So like there's a lot of support, even though it's hard, there's a lot of support.
Mm-hmm. Yeah.
So harder, but also university is really fun. So like there's a lot of benefits that you get from it as well.
Yeah. You're going for any degrees. So engineering it's a Bachelor of Engineering, so it is a degree. So hopefully we will be getting that in May.
Yeah, the next question is, do you have a bachelor's of science? So we in May, hopefully, we will be getting a bachelor's of science in engineering, or in chemical engineering.
Yeah. So
that will be our degree when we graduate.
Would you suggest going to Dal for the first 2 years or at one of the other universities that you named? That is 100% up to you. Mm-hmm. So I went to Dal. I had great experience. Caitlin went to St. FX. I'm sure you can say that you had experience.
I had a great experience. I'd say the biggest difference is that your classes at Dal for the first 2 years are going to be quite large.
Yes.
Your classes at the associate universities, so Acadia, St. FX, CBU, they're going to be quite a bit smaller. Most of them are. So you kind of get that small university feel for your whole 4 years. So I haven't had very many classes over like 50 to 75 students, which might sound like a lot if you're in junior high or high school right now, but lots of university courses are like 150, 200 students.
My
So
chem class was 400.
yeah.
In first year, yeah. So like it really just kind of depends on you personally, like, and also where you want to be. Like maybe you love Halifax.
Yeah.
Maybe you want to be in Antigonish.
Maybe you want your X-ray.
Yeah, there's that. It's definitely a personal choice. But if you are someone who prefers smaller class sizes, then I would say the smaller universities are probably a good choice, but don't be intimidated by the big class sizes. It doesn't mean that you don't get time with your teachers. Like they assign a number of TAs so that you have the option to talk, just like to get support from a TA or a teacher at any time. So it's not a disadvantage either way.
Yeah, for sure. Hello, which high school sciences are required for this major? Could I still apply if I took bio and chem, no physics?
I think you need physics.
I think you need physics. But if you're really interested in engineering right now, you probably could apply to take physics next semester. Or there's lots of summer courses available to do it online. So if you were like, oh, I really want engineering. The other thing is you could possibly apply to science and then switch into engineering after your first year. You might just have to take physics somewhere along the way, your high school physics somewhere along the way, but I have faith in you, you can do it.
Also on that note, like you take a first year physics class in engineering, but after that you don't have to see it again. So if you really hate physics, you basically just have to get through that one course and that's the end of it. Yeah.
Olivia, what does a typical day at work look like for chemical engineer?
Work or school? Both, I guess. Start with school.
Start with school. So we have courses almost all day, usually. So I'd say from experience from the past 4 years, how it usually works is you have classes all morning and then you have labs in the afternoon. It's not always like that, but that's what a typical day looks like. And then you might do a few hours of homework after your lab and then have dinner with your friends at meal hall. And then depending on what day of the week it is, maybe go do an activity after that.
Yeah, like that changes too, like throughout the semester. Like obviously there's times where things are a bit more chill. And then, you know, there's midterms exams where you're probably spending more time doing homework than you'd like to be, but it's short.
Yeah.
So,
and for like the first few weeks, like pretty much all of September, you have almost the whole weekend to yourself. And then you sometimes do like homework on Sunday afternoon, but you usually can give yourself at least a day and a half to do something fun. That's what I found anyways.
It's also important to find that balance. Like you could spend every day doing homework, and I've definitely done it at certain points in the semester, but you just kind of burn out. So you got to make sure that you are taking time to take a break, and you can always afford a short break, even if you don't feel like you can.
Yeah. But the typical day at work, I'd say chemical engineering is like typically 70% desk work, 30% field. Would that be fair, or would you say it's 50%?
Yeah, it depends on your like what industry you're in.
Maybe 60-40.
Yeah, like if you're in a more research-based like job, you're probably spending more time in a lab than at your desk. So maybe it's a bit higher of a percentage. So like maybe 50-50 or 60-40 or something. Yeah. If you're doing more project management, you're probably spending less time in the field, more time at a desk, meetings, that kind of stuff. I'm trying to think, like my co-ops were pretty split because like my last one, at least field work meant like flying to site. So it was like you fly there for a few days and then you fly back. So it's a bit hard to do kind of a day-to-day split. Because the days you're on site, you're fully on site, that's all you do. And then the days you're in the office, you're 100% in the office. But there's definitely a good mix of field work, lab work, stuff like that, compared to sitting at a desk and doing calculations or reports or whatever you might be doing. Any other questions?